What if 4 alien worlds were suddenly dropped into our solar system today? Which world survives? Which one melts? And which one starts a chain reaction that could rewrite Earth's future? Stay with me to the end. The last scenario explains how a single nudge could do more, possibly save our planet. I'm placing 4 real exoplanets into our solar system, one at a time. For each I'll explain what happens to the planet and what happens to us. No fluff, short timelines and long-term consequences. First, TRAPPIST-1e, slightly smaller than Earth and once considered one of the best Earth-like candidates. If placed at Mercury's orbit, TRAPPIST-1e would be scorched. Any liquid water would evaporate within years. The surface would desiccate and any atmosphere would be altered or stripped. It would appear as a bright dot in our sky, but gravitationally it would not immediately shred the solar system. If placed in the main asteroid belt, TRAPPIST-1e would freeze and lock remaining water as ice. Over millions of years, its gravity would tug on the asteroid population, scattering bodies inward. That slow destabilization could nudge Mars and, eventually, Earth's orbit, increasing the long-term risk of catastrophic impacts. Small size doesn't mean small consequences: immediate radiation death at Mercury, and subtle, long-term chaos in the belt. Next, Kepler-4, for to be a true super-Earth about 1.3 times Earth's radius and roughly 2.3 times its mass. Placed at half an astronomical unit from the Sun, it becomes a super mass. Oceans would evaporate into a dense high-pressure atmosphere that this planet's stronger gravity would hold tightly. Surface temperatures would skyrocket and any chance for habitability disappears instantly. Systemically, its greater mass would slowly perturb Mercury, Venus, Earth, and Mars. Over thousands to millions of years, those perturbations could push planets onto new tracks, trigger collisions, or shift climates dramatically. Close and massive equals immediate hostile climate plus long-term orbital instability. Third, Ogle 2005 BLG 390LB, known as OGL. A cold heavyweight discovered by microlensing with roughly 5.5 times Earth's mass. Placed in the asteroid belt, Ogle would stay frozen at first, but localized heating could sublimate surface ices and create a thin atmosphere. The real danger is gravitational. Ogle would pull asteroids from stable orbits and shepherd them inward. Within a few million years, the main belt could break apart, sending a bombardment wave into the inner solar system. That spike in impacts would raise the probability of extinction-level collisions on Earth. Quiet at first, then a delayed but brutal delivery of destruction a slow-fuse civilization might not see until it's almost too late. Fourth, J1407b. An epic super Saturn, roughly 20 times Saturn's mass, with rings hundreds of times wider than Saturn's, placed between Saturn and Uranus. J1407b would be a spectacle, its rings dominating the outer sky. But beauty masks danger. Its enormous gravity would slowly tug at Saturn and Uranus, destabilize moons, and fling Kuiper belt objects inward. Even a small nudge to Jupiter from these interactions could begin a cascading domino effect. Jupiter normally stabilizes the inner system. Disturb Jupiter and those disturbances can transmit inward. Over tens to hundreds of millions of years, that cascade could alter Earth's orbital eccentricity or spike impact rates. A spectacular sight could become a system-level threat, for very different worlds, for distinct failure modes. TRAPPIST-1e, immediate thermal loss at close distance and subtle long-term chaos in the belt. Kepler-4, for 2b runaway greenhouse and orbital perturbation. Ogle delayed but devastating bombardment. J1407b outer system gravitational dominoes. The common drivers are distance to the Sun and planetary mass. Close means heat, massive means gravitational trouble. In T underestimate belts. Asteroid and Kuiper reservoirs are latent threats because they hold the material that can be sent inward. Here's the real question: if one of these scenarios started unfolding tomorrow, what would we do? Deflection technology, planetary engineering, evacuations. In a follow-up piece, I'll map realistic survival strategies, timelines, required resources, and which actions could actually work. Vote in the comments which scenario you want prioritized first. If you found this deep dive valuable, like, subscribe, and hit the bell. I post science breakdowns like this regularly.